Planet Earth. That shiny blue marble that has fascinated humanity since they first began to walk across its surface. It remains the only planet we know of where life thrives. And over the course of the past few centuries, we have learned much about Earth, which has only deepened our fascination with it. Plate tectonics keep the planet comfortable. Earth is the only planet in the solar system with plate tectonics. Basically, the outer crust of the Earth is broken up into regions known as tectonic plates. These are floating on top of the magma interior of the Earth and can move against one another. When two plates collide, one plate will subduct, go underneath another. And where they pull apart, they will allow fresh crust to form. This process is very important, and for a number of reasons. Not only does it lead to tectonic resurfacing and geological activity, i.e. earthquakes, volcanic eruptions, mountain building, and oceanic trench formation, it is also intrinsic to the carbon cycle. Earth is mostly iron, oxygen and silicon. You could separate the Earth out into piles of material, you'd get 32.1% iron, 30.1% oxygen, 15.1% silicon, and 13.9% magnesium. Of course, most of this iron is actually located at the core of the Earth. If you could actually get down and sample the core, it would be 88% iron. And if you sampled the Earth's crust, you'd find that 47% of it is oxygen. A year on Earth isn't 365 days. It's actually 365.2564 days. It's this extra 0.2564 days that creates the need for a leap year once every 4 years. That's why we tack on an extra day in February. Every 4 years minus 2004, 2008, 2012, etc. The exceptions to this rule is if the year in question is divisible by 100, 1900, 2100, etc., unless it divisible by 400, 1600, 2000, etc. The Earth's molten iron core creates a magnetic field. The Earth is like a great big magnet, with poles at the top and bottom near to the actual geographic poles. The magnetic field it creates extends thousands of kilometers out from the surface of the Earth, forming a region called the Magnetosphere. This magnetic field is generated by the molten outer core of the Earth, where heat creates convection motions of conducting materials to generate electric currents. Be grateful for the magnetosphere. Without it, particles from the sun's solar wind would hit the Earth directly, exposing the surface of the planet to significant amounts of radiation. Instead, the magnetosphere channels the solar wind around.